Okay, this is our kind of our summary of linear relations. We're kind of going a little fast in this particular unit, but I'm teaching you all of the expectations right away. And then what we'll do, Jesse, is as we go through the chapter, we'll make sure we reinforce each of these particular skills with different questions. So basically, this chapter in linear relations, the goal is if you're given one type of thing, either a graph or an equation or a table of values, using that one that you're given, you can give me the other two. So in question number one, I give you a graph. Now the expectation is you can take a graph and you can make a table of values. And what you learned today, you can then take a table of values and create an equation that represents the relationship between x and y. So if we look here, the first thing I do is make my table of values. I'm going to put x and y here. And my x values are all of these values on the horizontal axis. So the first x value I have is 1, then I have 2, then I have 3. And if I see here, when x is 1, y is 5. So I'm going to put 5 up here next to that. When x is 2, the y value, which is your, I should say, is your vertical axis, is 15. And when finally x is 3, y is 25. So we've created what we call a table of values. And this shows the relationship between the x values and the y values in the linear relation. And what we mean by linear relation is when I connect those dots, it forms a line so that, as we talked about earlier, we can use that line to sometimes read values in between there, which is called interpolation, or we can read values beyond the points, which is called extrapolation, and we can figure out other values as well. But the easiest way for us to find values is to find the equation, the algebraic equation, that matches the table of values. And the easiest way to do that is to find the difference in x, and hang on a second. Okay, so if we look at our table of values, we had 1, 5, 2, 15, and 3, 25. One of the easiest things is this little, it's called actually slope, but we're not going to learn slope until grade 10. What all we want to think of now is the coefficient that shows the relationship between x and y will be the difference in the y column divided by the difference in the x. So if I look in this y column, the difference between 5 and 15 is 10. And the difference between the 15 and the 25 is 10. And in the x column, the difference between 1 and 2 is 1. And the difference between 2 and 3 is 1. So the difference in the y column is 10. And the difference between the x column is 1. And 10 divided by 1 is 10. That means that in the equation that shows the relationship between x and y, I know that my coefficient is going to be 10. Now the next step is to figure out if there is a constant needed. And in order to do that, I just have to go into any ordered pair in my table of values. In this case, I'll take the first one, 1 and 5. And what I'm going to do is I'm basically just going to substitute it. So x is going to be 1, and y is going to be 5. And I'm going to see if these two sides are even. So 10 times 1 is 10, and 10 is not equal to 5. So the constant I need is actually to take away 5, and then I would have a balance between the two sides. So my constant is minus 5, so therefore I'll add it into my equation. I have a very Christmassy looking equation. I have the equation 10 times the x value minus 5 will always give me the corresponding y value. So if I take this pair and check to see if it works, the x value is 3, so I'll put 3 there. And the y value is 25, so I'll put that there. And I'll check to see if both sides are equal. 30 take away 5 is 25, so therefore x is 3 and y is 25 works for that equation. So, what's the good of that? Well, I can do a whole lot of different stuff that we're going to look at later, but right now, that would be the equation that matches that value. In the second one, it says, what is the graph for this particular equation? So what I'm going to do is I'm going to just create a simple xy axis. I'm going to put 1, 2, 3, 4, 5, 6 here. So 1, 2, 3, 4, 5, 6. And it goes from 10 to 14 to 18. So what I'm going to do here is I'm going to take my eraser, and I'm going to erase a little bit here, and I'm going to put this little marker in. And what that means is I've kind of crushed that y-axis down a bit. And the first number I'm going to put in here is 10, and then 14, and then 18, and then whatever else I want. Basically, I eliminated 2, 4, 6, 8, and all of those. So I need to put that in there because technically this should start up a little bit higher on the y-axis, but we're going to start there. So the first value, 210, would be this point. 414 would be this point, and 618 would be this point, and there's my line. So when I graph that table of values, it makes this linear relation on the graph. The second thing I need to do is figure out what my equation is. So I'm going to use that method to figure out my coefficients. So my x equals y. I'm going to figure out what my coefficient is. The difference here is 4 in both times. The difference here is 2 in both times. So take the difference in y divided by the difference in x. 4 divided by 2 tells me I have a 2 coefficient. Use that first pair of 2, 10. Substitute it in. 2 is my x. 10 is my y. 4 does not equal 10, but if I add 6 to it, it does. So then I know that my equation must be 2x plus 6 equals the y value. In the third question, 2x plus 1 equals y. My graph, I cannot do my graph yet. I need to have what first? I'll always need to have a table of values first. So I'm going to put x and y down. And if there are no values given, I'm just going to put 1, 2, and 3. Okay? And then in order to figure out the corresponding y value, I'm simply going to substitute each of those x values in to determine the y. So 2 times 1 is 2, plus 1 makes my y value 3. If x is 2, 2 times 2 is 4, plus 1 is 5. And if x is 3, 2 times 3 is 6, plus 1 would be 7. Once I have that, then I can graph it. So I'm going to put 1, 2, and 3, and 4 here. And I'm going to put 2, 4, 6, and 8 here. Those would be 1s. So 1 would be 3, 2 would be 5, 3 would be 7. There's my line. And that would be the graph that represents 2x plus 1. And the final question is, what is the equation that matches this? Now remember, my difference here is 1, and my difference here is 4. And like we said before, if you want to find the coefficient that shows the relationship between x and y, the difference in y, which is 1, divided by the difference in x, which is 4, will tell me my coefficient. Therefore, my coefficient is either a quarter, or the best way to show a quarter is that way. So then I go back and substitute to see if it's actually, if it needs a constant. Oops, my 4 is gone. A quarter of 4 is 1, so it works. A quarter of 8 is 2, that works. So really, I don't need a constant. My equation is simply a quarter of x equals y.